In this tutorial, we will see how to sketch the graph of a quadratic function. We are asked to sketch the graph of the quadratic function given by y equals negative 3x squared plus 6x plus 24 by finding the vertex. Knowing how to sketch is valuable since functions like this often model things like revenue and profit, for example. A general quadratic equation has the form y equals ax squared plus bx plus c, where a, b, and c are called coefficients. For us, they are real numbers. In our case, a equals negative 3, b equals 6, and c equals 24. We also know the graph of a quadratic function is a parabola. In order to sketch the graph of a parabola, we need to know its vertex, the direction the parabola opens, either up or down, the y-intercept, and if it has any x-intercepts. We know that a parabola always has a y-intercept, but doesn't necessarily have x-intercepts. A parabola can have 0, 1, or 2 x-intercepts. So let's compute each of the items I just mentioned. First, we'll talk about the vertex. The vertex is a special point that we label h, k. H is given by the formula h equals negative b divided by 2a. And k equals f at h. Since we know a equals negative 3 and b equals 6, we can substitute these values. After simplifying, we get h equals 1. Then k is found by substituting 1 into the original function. In other words, k equals f of h, which equals f of 1. After simplifying, we get k equals 27. Therefore, the vertex is the point 1, 27. Next, we want to know if the parabola opens up or down. The sign of the coefficient a determines this. Since a equals negative 3, it is negative, and so the parabola opens down. A positive number would indicate that the parabola opens up. Now we want to know where the parabola crosses the y-axis. In other words, we want to find the y-intercept. We do this by setting x equal to 0. That gives us the following equation. We see that after simplifying, we get y equals 24. This gives us a point 0, 24. Finally, we want to know if the parabola crosses the x-axis. In other words, we want to find the x-intercepts. Remember that parabolas don't necessarily have x-intercepts, but given what we've already found, there's a way for us to tell right away if ours does or not. We observe that the vertex 1, 27 lies above the x-axis. Since the parabola is opening downward, it must cross the x-axis at exactly 2 distinct points. So to find the x-intercepts, we're going to set y equal to 0. This gives us the following equation. We can divide both sides by -3 to simplify the equation before we factor it. This simplified equation factors nicely since the roots are whole numbers. Now, since the product of x minus 4 and x plus 2 equals 0, we can set them both individually to 0. So we obtain x equals 4 and x equals 2.
-2.
That means we have 2 x-intercepts. So this gives us 2 points. The first is 4, 0, and the second is -2, 0, which both lie on the x-axis. Now we can sketch the graph. A complete graph includes labeling the x and y axes. Then we label the vertex and any intercepts. This completes the exercise.